All right, ladies and gentlemen, this is video 4 of 5. I know this lesson is lengthy and I appreciate your patience and hard work in solving this. This is going to show us an example of how to solve for the area and perimeter of a regular polygon when we are given the radius. Once again, to start the problem, you will always know two things. One, you'll be able to tell what shape it is. In this case, it's an octagon, which means n is 8. That's the first thing that we know just from the picture. The second thing we know is that the value we're given in this problem connects the center to a vertex. That means our radius is 4 meters. So we know the number of sides and the radius. So we start off the same way we did in the last example. Step 1 is to find theta, and we use our theta equation for that, which is 180 times n minus 2 divided by n, or 180 times 8 minus 2 divided by 8. Now octagons are kind of unique. They're one of the few that does not give us a whole number answer. Oh, I lied, they do. That is a 135-degree angle. I was thinking about, I think, decagons. Anyway, the interior angle is 135 degrees. Now remember, what we really need, though, is not theta. It's half theta, theta divided by 2. So while we're here, we're going to go ahead and divide 135 by 2, which is 67.5 degrees. That's the value we need because that's the value we're going to be plugging into our equations. Now remember that to find perimeter and area, we need to know the number of sides, we need to know the length of the apothem, and we need to know the side length. Right now, all we know is the radius. So what we're going to do is we have to use both of these equations, this one to find A and this one to find S. So we start with this one to find the apothem. That'll be step 2, is to find the apothem. And we do that with the equation A equals R times the sine of theta over 2. In this case, that would be 4 sine 67.5. We feed that to our calculator. 4 times the sine of 67.5. And since the directions call for 2 decimal places in our final answer, we keep 3 decimal places for the purposes of calculations. So in this case, that would be 3.6955, so we would round that first 5 up to a 6. 3.696 units would be meters, not that units matter at this point. Now we're going to find the side length. We do that using the other equation from earlier in the problem. S equals 2R times the cosine of theta over 2. So that's 2 times 4 times the cosine of 67.5. We feed that to the calculator. And again, we're going to keep 3 decimal places. So we're going to say 3.061 meters. So now we know what we need to know to find the area and perimeter. We know the number of sides, which is 8. We know the apothem is 3.696. And we know the side length is 3.061. So we start with perimeter, which is number of sides times side length. That is 8 times 3.061. We're going to round that off to 2 decimal places. 8 times 3.061 is going to be about 24.49 meters. So there's our perimeter, 24.49 meters. Then we do area. Area is 1/2 NAS. That'd be 1/2 times 8 times the apothem, which we said is 3.696, times the side length, which is 3.061. Feed that to the calculator. Round to 2 decimal places. That would be 45.25 square meters is the area. And that is how we approach the problem when we are given the radius. Again, this example shows what we do when we are given a radius. Every single time that you're given the radius, you'll follow these exact steps to find the perimeter and the area. That's it for the second to last video. We have one video to go. It will be an example of how to do this problem when we are given a side length. Thank you for your time.